Hello everyone, welcome to Calculus. Today we are going to be looking at section 1.1, families of functions, and we'll also be looking at how to transform those families of functions. So in earlier classes, we're going to work on this part today. In earlier classes, you learned about parent functions, and so this page of your notes packet, it looks like it's on page about 4, gives you a picture of all the functions that you've studied leading up to this point. So this first one, this y equals a, the a is going to stand for a constant. So it looks like, I'm going to guess, maybe this is about 4, like y equals 4. Anytime you have y equals a number, you'll have a horizontal line. And that would be true if y were equal to 3 or y would be equal to 2. We're just going to have a flat horizontal line. We call this family of functions the constant family. Anytime you have something with y equals x, where x is raised to the first power, that is the linear function family. When you've got an x squared and the 2 is the highest exponent, that's the quadratic family. X cubed is the cubic function family. The square root of x, y equals square root of x, we call that those square root functions. And we're actually missing the cube root function, so if you want to add a cube root function on here, here's the x and y axis. It ends up having a shape like this. And when this is of the form y equals x cubed, so we have the cubed root. Then we've got our absolute value function for y equals absolute value of x. Y equals 1 over x is the rational function. Then we have y equals the natural log of x. And then y equals e to the x and y equals e to the x. These are both exponential functions. But the one that increases is called our growth exponential function. The one that decreases is the decay. And then y equals sine of x and y equals cosine of x. So I'm going pretty quickly because I think you have seen these in the past. But the idea in front of you is that you need to be able to look at any formula or any equation for a graph. So let's say I gave you y equals square root of 5x plus 2. If you see something like that, I would like your brain to think, oh, okay, a square root function is going to have this type of shape. That's the goal here. So spot a formula and then know what kind of shape you're going to see. So let's say if I had y equals 1 over x plus 2. Oh, that's a rational function, so I know it's going to have a shape similar to something like this. Now, it might be shifted left, right, up, or down, but it's going to have this type of shape. Now, how do I take a parent function and shift it around? Here are the rules. So we've got our notation, and we can see how we're going to shift something up, down, left, or right. So it says to use the parabolic function y equals x squared as an example. So that means we want to use our formula y equals x squared as our parent function. And let's say we wanted to move the graph up. If I want to move a graph up a certain number of units, let's say I was going to move it up 2 units, then I need to add a number outside of the grouping symbol. Now, grouping symbols are things like parentheses, square roots, fraction bars. And on the equation y equals x squared, I'm not seeing any parentheses or any other grouping symbols, so I'm just going to go ahead and add them. Y equals x, parentheses, squared. So if I want to move the function up 2 units, I'll take y equals x squared. I'll have and then add 2 outside. If I want to shift it down 2 units, we're going to say all these a's are 2's. Y equals x squared minus 2. Now if I want to move it to the left, I'm going to add a number inside the grouping symbol, so that would look like y equals x plus 2 squared. That's going to shift it left 2. And that plus is going to make it feel like the opposite, but that's how it is. And then minus a, y equals, if I want to go to the right, x minus 2 squared. Now vertical stretch. Vertical stretch is going to take our parent function and stretch it. If you imagine, like, if this is a rubber band and I were to pull that rubber band down and get a more narrow picture of a parabola. So what that does is I have a number out front of x squared, out front of the function. So let's say that a was 2. So this formula would be y equals 2 times x squared. And so what this does to the points, you're going to keep the x values the same for the parent function, but then you're going to multiply all the y values by 2. So let's talk about that. My parent function, y equals x squared, I know has points at 0, 0, 1, 1, and 2, 4. On the transformed function y equals 2x squared, all those x values of the points are going to stay the same, but the y values are going to be multiplied by 2. So 0, 2, 1 times 2 is 2, 4 times 2 is 8. Those would be the points on my transformed graph. Okay. Vertical shrink will work the same way. The only difference is that you'll see a fraction. So 1/2, y equals 1/2 x squared, but you can do the same thing. Keep the x values the same, then multiply the y values by 2. All right? Then we'll skip down to reflection. If there's a negative in front of the entire thing versus a negative just within the grouping symbol, you'll have a reflection across the x versus reflection across the y. Now, one thing you need to remember is that just like we follow order of operations to do math, we still follow order of operations for our transformations. So if I have the parent function y equals the square root of x, and then I also have the function y equals the negative square root of x minus 2 plus 4. There are 3 different transformations. Ooh, I need a highlighter there. Hold on a second. There are 3 different transformations that's happening. There's one for that negative. There's a transformation for the minus 2 inside. And then there's a transformation for the plus 4. So I want to make sure that I'm following the order of operations. Order of operations tell me that I need to start inside the grouping symbol first. So I need to do this one first, which means I need to shift my parent function right 2 units because of the minus 2. Then if I were to follow order of operations, I would do multiplication, which would be the negative. So I would reflect across the x-axis. And then finally, because of that plus 4, that's the last thing I'm going to do, I would shift everything up 4 units. So you'll see on your assignment, you've got several of couple different scenarios to try. Take these notes, try those examples, and I will be happy to help whenever you get stuck. Have a wonderful day.